Hello and Namaste. In continuation of the complex variables, we'll be going ahead with the construction of an analytic function using Milne Thomson method, wherein the imaginary part v is been given or known. So construction as we have done it for the u when the real part of the function has been given and we have found out, the same way we have to do it in for the imaginary part has been given. So what is my first step? First step is dou v upon dou x and dou v upon dou y, because the v part is known to us. So we have to find out, differentiate v with respect to x, differentiate v with respect to y. Next step is we have to differentiate f of z. Okay, so we have already seen that this f of z is nothing but u plus iv, and if we are differentiating z with respect to x, it will give me dou u upon dou x plus I times dou v upon dou x, right? Now we have been given the imaginary part. That means what? We don't know the real part of the function, and therefore we have to use the CR equations. That is, dou u upon dou x is same as dou v upon dou y, and dou u upon dou y is same as minus of dou v upon dou x, and therefore after substituting that CR equations, we can go ahead with dou v upon dou y plus I times dou v upon dou x. So f dash of z will be getting as dou v upon dou y plus I times dou v upon dou x. Then the same thing what we have done it again, this is a very important step as I have told you for the previous session as well. This is x is equals to z and y is equals to 0 in this f dash of z, and then we have to integrate f dash of z to obtain f of z. Let us go and see few examples over here. Find the analytic function w is equals to u plus iv, whose imaginary part has been given by this function. So it's e to the power x, x into sine y plus y into sine of y, cos of y. So what is my first step? First step is saying that I have to differentiate v with respect to x, differentiate v with respect to y, both of them. So if I am differentiating with respect to x, now this is the differentiation of this. So it is first function as it is, that is e to the power x, into differentiation of the second function as it is, and to differentiation of first function, because it's a both of the function e to the power x and x into sine of y plus cos of y. So so what we have done, this as the first, this as the second function, and we have just differentiating this v with respect to x into u into v part, right? So this is v as it is. So you can say that first function as it is, then the differentiation of the first function, second function, and so on. So here what we have done it here, this is the second step I have done it here. First function as it is into differentiation of the second with respect to x will give me just sine of y, because this term, this y times cos of y is free from x, or you can say the constant with respect to x, plus e to the power x into x sine of y plus y times cos of y. So this second term will remain as it is, and differentiation of the first. Therefore, and the same dou v upon dou x will give me the same way. I have to, because here u into v rule will be, the second part will be 0, because if you'll observe, e to the power x is the function of x only, there is no y, and therefore the differentiation of e to the power x will give me 0, right? And therefore e to the power x into differentiation of this particular function with respect to y will give me x into sine, differentiation of sine of y will give me cos of y, plus now again this y into cos of y will be again in terms of u into v as cos of y minus y times sine of y, because it's y and cos of y, both of them as the functions of y, and therefore this is the differentiation of this v with respect to x. Then after that f dash of z is this, which is dou u upon dou x plus I times dou v upon dou x. Then we are replacing dou u upon dou x by dou v upon dou y, and then just putting the values over here, right? Just then the values of dou v upon dou y and dou v upon dou x. Dou v upon dou y is this, dou v upon dou x is this, plus I times, right? Of course it's this, there is a I times over here, so just we have combined everything together. Then putting x is equals to z and y is 0. So whenever I have got y with sign, that will move to 0. So this will move to 0, this will move to 0, this will also move to 0, because it's y present here, right? Now similarly, this y into sine y, this term will move to 0. Cos of y will give me 1, because cos of 0, right? And this will also give me some value. So if you'll observe, this is the step what we have done it here, and therefore I am getting f dash of z as e to the power z into z plus 1. So it's a very simple function, we have got it. Now we have to just integrate this particular function with respect to z. And therefore the differentiation, again, as I have told you, we have already discussed many a times that the integration by parts, right, and this is the first function, this is the second function, first function as it is, differentiation of the second, and so on. So this is the first function because it's algebraic function, LIATE rule. And okay, I think I have put down, just a minute. Yeah, and so this is the first function, this is the second function, and we have to go first function as it is, second function, integration of the second minus the first function, differentiation of the first will give me 1 into integration of the second plus c, and therefore we have got z into e to the power z plus c as the function for this particular function, right? And then the next question is this is u plus, I need to find out f of z, u plus iv, and where v has been given to us as this. Now again differentiating v with respect to x, differentiating v with respect to y. Now because if you'll observe here, they are the very simple function. If you'll observe, it's u by v rule, which I have already observed. Please follow the I button to get the help of the u by v rule here. And therefore it's 2 times sine of hyperbolic y. So because I am differentiating with respect to x, sine hyperbolic y will come out, and this is the u by v rule will go here for the differentiation here. So cos of 2x plus cos hyperbolic 2y as it is into differentiation of sine x, that is cos of x, minus sine x as it is into differentiation of the denominator with respect to x will give us minus of 2 times sine of 2x upon into product, or the, you can say, the square of the denominator. And differentiating with respect to y here, so this at that time this numerator 2 times sine of x will be constant, and remaining sine hyperbolic y upon cos, so this will be u by v rule. So cos hyperbolic, so sine of 2 cos of 2x plus cos hyperbolic 2y into cos hyperbolic y, because sine hyperbolic y, the differentiation will give me cos hyperbolic y, minus sine hyperbolic y as it is into differentiation of the denominator will give me 2 times sine hyperbolic 2y upon this, right? This is by u by v rule of differentiation. Then f dash of z, and then we are putting the values over here. After this we'll be putting x is equals to z, y is equals to 0. So whenever I have got the y with sine function, that term will move to 0. Similarly, if you observe here, if you'll observe here, this is the term which will move to 0. Let me check other functions, other terms over here. So if you'll observe, this sine hyperbolic y is there in the product, so everything will move to 0. No need to see what will happen with the other terms, because one term is 0, that means the other product will give me 0. And this is what, yeah, yes, and therefore it is f dash of z is 2 times, so every x been replaced as z, every y been replaced as 0. So it's 2 times sine of z into this entire thing. That will simplify me and give me this answer as 2 times sine of z into cos of 2z plus 1 upon cos of 2z plus 1 the whole square, and which is nothing but 2 times sine of z upon cos of 2z plus 1. This will give me 2 times sine z plus equals to 2 times 2 sine z upon 2 times cos of cos square z, which is tan z into sec of z, right? And this will give me, now I have to integrate with respect to z, will give me here the integration of tan z into sec of z dz will give me sec of z plus c, and this is what is the final answer for this particular question, which is equals to sec of z plus c, sec of z plus c. Okay, and we have got this as, this is a self-observation slide wherein you have to find out the f of z, or you can say w, when the u part has been given to you along with the answers given to you here. If at all any query, please write me in the comment section so that I can address those questions. Thank you. Happy learning.